Okay, thank you. Hello, everyone. I hope that you are all doing well. And as part of the Plant Bee Prima project, in this presentation, we are going to present the results according to the work package 3 and the subtask 3.4.2. Okay. Our study is entitled Impact Study of the European Bee-Eater on the fertilization rate of Saharan queens and Telian queens. In Algeria, the Telian bee and the Saharan bee are two distant geographical subspecies. The Telian bee populate the entire northern part of the country, and the Saharan bee has as a natural cradle the southern west of the country. I'm going to show you the this one. In this photo, we present the Saharan bee, Apis mellifera sahariensis, which is characterized by yellow color. And the Telian bee, which is characterized by black coral, and these two bees are very distinguished by several physiological and behavioral criteria. The Saharan bee lives in a difficult climate. It suffers of several natural and anthropic traits that made her in danger of extinction. First, for the natural factors, we have drought, desertification, lack of food resources, and sirocco, which is climate change. And in 2004, there was a major invasion of locusts in Algeria, and especially in Ain Safra. The authorities were obliged to fight this invasion by aerial spraying with chemicals, which have reached large areas and also apiaries. We see in the picture thousands of dead crickets around the hive, killed by chemicals. As a result, bees are dead because of locust control chemicals. And we can see also live bees with pollen in this photo. And hopefully the locust invasions happen occasionally. Another problem of the Saharan bee is hybridation with the Telian bee. So thousands of hives are moved from the north of the of the country to the region of Ain Safra and its surrounding to enjoy the season of the jujube, Ziziphus lotus, and the period of honeydew. As a sequences, the Saharan is not longer an obstacle between the Telian and the Saharan bee, so they end up side by side. The Saharan will be fertilized. The Saharan bee will be fertilized with the males of the Telian bee, invading the area. So we have unwanted hybrids. In the photo, we see a colony of mixed bees. We can clearly distinguish the Saharan yellow bees and the Telian black bees. And in its natural environment, the Saharan bee has a predator, which is the European bee-eater. The European bee-eater nests in late spring in Ain Safra and cause damages to the apiaries. It is considered as a serious threat, especially during breeding periods. The European bee-eater is a migratory bird. Its nests in the arid zones of Africa. It's across the Mediterranean Sea and the Algerian Sahara. And the insecra is part of its migratory route. It is an insectivorous bird. Its diet is composed mainly of Hymenoptera, bumblebees, wasps, and especially bees. After several Saharan bee queen multiplication series, it was noted that in the presence of the bee-eater, the fertilization rates change from the period when the bee-eater was absent. The purpose of this study is to evaluate the impact of the presence of the bee-eater on the fertilization rate of the Saharan queen. And the Telian bee was added to make a comparison between the two subspecies. The experiment was conducted in two different sites. The first study site is located in breeding apiary at the Apidology Laboratory in the University of Boumerdès. The second experiment was conducted in another fertilization apiary in La Grotte, which is 400 kilometers from Algiers. Note that this area is in the route of migratory bird. The experiment was carried out in two different periods of the year. The first period took place in March and in the absence of the European bee-eater. And the second period was in the month of May in the presence of the European bee-eater. So to do this task, queen breeding, we used the Dolittle and Path method for our breeding for all the strains. Horizontal double broad hive was used for breeding. It contained two compartments with a vertical queen grill that separate them. On the right, the queen confined, and on the left, the orphan compartment to receive the breeding from. In order to successfully perform our grafting operation, we choose larvae less than 24 hours. The royal cells operculated on the 5th day were the subject of the first selection, which consists in retaining that only the heaviest cells. The photo on the left shows a good capped cells from, and the photo on the right, we can see the cells of the queen cells sorted and numbered to be used later. When we put these queen cells and incubated and an artificial incubator at 34 degrees and 70% humidity until their emergence. From the 12th to the 13th day of grafting, the queens began to emerge. For the Saharan queens, we retained only the yellow queens. Then we put them in the nucleus with the 4 compartments. Each compartment contains 2 frames populated with bees, and the third one is a supply with honey and pollen. Every compartment has a queen. This photo shows a queen introduced into the nucleus that was accepted by the bees. We also closed the flight holes with a queen gray to prevent the queen from coming out, and we transported the nuclei to the fertilization apiary in Al-Gawad. We placed 4 strong male-providing colonies to flood the area with males. The fertilization of the queen was done naturally in the air. 10 days after the introduction of the queen, we check all the nucleus. If there is a presence of laying, means that the queen has been fertilized. The photo shows eggs newly laid by the queen. If eggs are seen in the same cells like this picture, it means that fertilization has not taken place, or the queen is not out for fertilization, or she didn't come back after the fertilization flight. During this visit, the number of queens present unfertilized is recorded, and in this case, appearance of laying workers, as we see in this photo. After a series of breeding carried out in March, in the absence of the bee-eater and in May, in the presence of the bee-eater, we had the following results. So in the absence of the bee-eater, the fertilization rate exceeds 18%, while in the presence of the bee-eater, the rate does not exceed 13% for both bees subspecies. Indeed, in the first case study, in the absence of the European bee-eater, we note that the fertilization rates were very high, with percentage of 84.8% for the Saharan bee and 83.1% for those Italian bees. The difference was not significant between the two breeds. And in the presence of the European bee-eater, there is a remarkable decrease in the fertilization rates of queen bees, with percentage of 33.7% for Saharan bee queens and 30% for those of Italian bee. And also the difference was not significant between the two breeds. In the absence of the bee-eater, the fertilization of the queens of both breeds was successful. The fertilization rate of both breeds was high. In the presence of the bee-eater, the fertilization rate of both breeds was low. So we have 3 hypotheses to explain this drop in fertilization rate in the case of the presence of the bee-eater. For the first hypothesis, the number of males was insufficient during mating. For the first case, the number of males in the fertilization apiary was low to ensure good fertilization of all the queens. And for the second case, the males were predated by the European bee-eater. The first case is not to be retained, because in March we put colonies of very strong males as in May, and we did not have a problem of availability of males. So we retained the second case. The males were predated by the European bee-eater. Indeed, the work of Paulo and Maria 2001 showed that the daily mortality of drones per hive due to predation by bee-eaters averaged 13% of their total daily mortality. For the second hypothesis, the queen was predated by the bee-eater when she came out for the nuptial flight. This hypothesis is to be retained because out of 67% of the unfertilized queens, there was a part that did not come out and another part come out and did not come back. We will give the results later. And our study is according to Ali and Taha 2012 and Flores and all 2020 research. They find that the bee eaters negatively affected queen mating, where the number and percentage of queen mating were significantly lower in the presence of the bee eater compared to its absence. For the third hypothesis, the queen did not come out for fear of being attacked by the bee eater. She wasn't fertilized, so she became a drone-laying queen. This photo shows a brood of males. We conclude that the geographical area of the Saharan bee is in the migration route of the bee eater. So, for successful queen breeding in this region, series of queen breeding must be programmed which do not coincide with the migration periods of the bee eater. And to know the quality of the queen, we must carry out two methods on direct and another one indirect. It is known that the flight of fertilization is a dangerous moment for the queen. Sometimes she made several flights to fill the spermatheca. We wonder if the queen has made the number of flights sufficient to fill her spermatheca, especially in the presence of the bee eater. For this, we are asking the question in this perspective is that the 30% of queens that we obtained are good quality queens. And to answer this question, there are two methods. We use the direct method, which is the counting of spermatheca and the spermatozoa and the spermatheca. After desiccating the fertilized queens, we see in the photo two types of spermatheca. The first one is full of sperm that indicated a good fertilization of the queen. And for the second photo, we see an empty spermatheca indicating that the queen has not been fertilized. And for the second one, either we use the indirect method and see the lifetime of the queen. We evaluate the quantity of farms of bird, and we will adopt this method in our studies. And thank you for your attention.